Namaskar. My name is SANDEEP CHAUDHARI, working as Assistant Professor in Department of Electrical Engineering, All India Shri Shivaji Memorial Society's Institute of Information Technology, AISSMS IOIT, Pune. This presentation is about Permanent Magnet Moving Coil, PMMC Instrument, Construction and Working. The presentation covers Working Principle of PMMC Instrument, Construction of PMMC Instrument, Advantages and disadvantages. Working principle of PMMC instrument. Current carrying conductor placed in a magnetic field experiences a force. So the current carrying conductor in PMMC instrument is in the form of coil, which is wound on former, and this assembly is arranged in a strong magnetic field produced by permanent magnets, NS poles. The moment this coil carries current, there is magnetic interaction and a force is experienced by the coil. This force is indeed proportional to the current flowing through the coil, and hence a deflection proportional to current is obtained. So this is in brief about working principle of PMMC instrument. Constructional details of PMMC instrument. As you can observe, a 2D sketch of PMMC instrument is drawn. An iron cylinder is provided. It is cylindrical in shape, and aluminum former is arranged on the iron cylinder. On aluminum former, a copper coil with definite number of turns is wound. This entire assembly is supported by a spindle which is made up of steel material, and the spindle vertical part is supported at both ends by means of jewel bearings. The spindle rotates along its axis as per the deflection of the coil. Two spirally wound springs are provided, one at the top side of the spindle and bottom side of the spindle. This spring will provide the necessary controlling torque required for this PMMC instrument. Flexible ligaments are provided at both sides of the coil, and these are connected to springs. So the flexible ligaments are actually current leads which can supply current to the coil, which is a moving member. This entire assembly is surrounded by strong permanent magnets, NS. A pointer made up of aluminum is attached to the spindle, and the moment this spindle rotates, the pointer also moves on a calibrated scale. So this is in brief about the constructional details. As you can observe, the symbol of PMMC instrument resembles the construction. This coil of instrument is surrounded by permanent magnets. So this is a U-shaped permanent magnet, and a coil is kept inside it. A square portion is a coil, and this U-shape is actually a horseshoe magnet. So this is about the symbol. For satisfactory working of any indicating instruments, there are three torques essential. One is deflecting torque, second controlling torque, and damping torque. Now deflecting torque will be produced by this coil. As we know the working principle, the coil carries current, so current carrying conductor is placed in a magnetic field and it will experience a force. The coil will be deflected. The deflection of coil causes rotation of the spindle, and that rotation is passed on to the pointer. The calibration of instrument is done such that this travel of this pointer on the dial is proportional to the current flowing through this coil. So this is about deflecting torque. The second torque required is controlling torque, which is provided by means of spirally wound springs, which are provided at both sides of the spindle. So the springs provide necessary controlling torque. Springs are made up of phosphor bronze material. Remember, the springs produce controlling torque and they also have electrical connection to them through flexible ligaments. So their purpose is to provide controlling torque as well as to provide arrangement for feeding current to the coil. So the electrical properties as well as mechanical properties of springs are important. The third torque is damping torque. Aluminum former provides the necessary damping torque. As we know, the deflecting torque and controlling torque act in opposite direction. So there are oscillations of the moving system, and these oscillations are not desired. So the oscillation should be damped. The aluminum former also oscillates due to deflecting torque and controlling torque, which act in opposite direction to each other, and it produces eddy currents. The eddy currents, as we know, as per Lenz's law, oppose the cause of producing them. So the cause of producing them is oscillations, and oscillations are damped. So in this way, we get deflecting torque, controlling torque, and damping torque in PMMC instrument. Some more sketches are shown in this slide, showing the different arrangements of magnet. This is a U-shaped magnet, permanent magnet, in which entire iron cylinder, aluminum former, and coil assembly is arranged. Vertical part is spindle, and springs are provided at both ends. Pointer is attached to the top. This is an expanded U-shaped magnet. You can observe cylindrical part, iron cylinder, the aluminum former and coil assembly, vertical rod, spindle, and springs at the both sides. This shows the cut section of the PMMC instrument. You can observe cylindrical core, iron core, then aluminum former and coil. The cylindrical iron core is provided to strengthen the magnetic flux linkage. What we expect is maximum flux linkage to the coil. That means the permanent magnets, NS poles, the entire flux ideally should link with the coil. So because of this iron cylinder, the entire flux pattern becomes radial. So maximum flux linkage is obtained at the coil side because of the iron cylinder. Remember, iron cylinder is a fixed member. It's not going to rotate. What is going to rotate is the aluminum former and the coil. Iron core, iron cylinder will be stationary when the instrument is functioning. So this is about the different arrangements of magnets, the entire constructional details of PMMC instrument. The deflecting torque on the coil, it is denoted by TD, and it is equal to NBIL into D, where N is the number of turns of coil, B is the flux density produced by permanent magnets, I is the current flowing through coil, L is the length of coil, and D is the width of coil occupied in the space between the two permanent magnets. Flux density is in Weber per meter square, current is in ampere, the coil length and width are in meters, and the torque unit is Newton meter. Advantages of PMMC instrument. From the deflecting torque equation, it is clear that it is proportional to current. So it's a linear relationship. So scale is uniformly divided. So it's convenient for the observer to note down the readings from the deflection of pointer because the scale is uniformly divided. Since the coil is very delicate and small, the power loss in the coil itself is very less. So power consumption of this instrument is very low. It is in milliwatt. The moving system is light in weight and operating magnetic field is strong. So that's why we get a high torque with a less weight of moving system. Hence, the torque to weight ratio of this instrument is high. And because of strong magnetic flux, we have got a good sensitivity. And because the operating magnetic flux of instrument itself is strong, the errors because of stray magnetic field. Stray magnetic field means external magnetic field, which causes interference in the instrument. So stray magnetic field error is negligibly small because the instrument itself has got strong magnetic field. This instrument is free from hysteresis and stray magnetic field errors. The eddy current damping, which is provided by aluminum former, is most effective because even if small oscillations are there, these are passed on to the aluminum former, and as we know, as per Lenz's law, it provides the necessary damping torque for the instrument. The single instrument can be used for various ranges. Simply we need to add some external resistances which are known as shunt and multiplier resistances. Shunt in case of ammeter and multiplier in case of voltmeter. So by just adding these external resistances, we can have the instrument to work for different ranges. The moving system has got high torque to weight ratio because the moving system is light in weight and operating magnetic flux is strong. Disadvantages: this instrument cannot be used for AC because if you connect it to AC supply, unidirectional torque is not possible. There will be oscillations of the moving system and pointer will not show you steady state deflection. So its use is restricted to DC. However, if you have AC supply, you have to rectify it and then use it and calibrate the scale as per the AC current. The cost is higher because of the construction. Its construction is delicate, number of parts for moving system are more, assembly work is quite delicate, so the cost is higher compared to the other instruments. Due to aging effect of the magnets, the magnetic flux may decay over a period of time. You have to handle this instrument very carefully because the construction is delicate, so it cannot withstand the high mechanical vibrations or shocks, so you have to operate it very carefully. Thermoelectric EMF may be present for high values of current and these may cause errors. So this is about the advantages and disadvantages of PMMC instrument. Thank you. For more information, you can log on to www.aissmsiot.org.